Welcome to your first lesson of Unit 3. Today you are going to learn how to determine the special points of a parabola when the equation is in vertex form. So the first thing we're going to start with is how you would solve for the zeros, and you can do that using isolation. To use isolation, what you want to do is use the opposite of BEDMAS, which is SAMDEB. So we start with this equation here, and since we're trying to find the zeros, the first thing you want to do is to substitute 0 in for f of x. So to use isolation, you're following the opposite of BEDMAS. So the first thing you're going to do is to remove whatever number is added or subtracted. So in this case, the positive 8 is being added or subtracted. So basically you are getting rid of the k value. So to get rid of the k value, you're going to subtract 8 from both sides. And then that will give you a negative 8 on the left. The next step is to get rid of whatever is being multiplied or divided. And in this case, it is the a value of negative 2. So you're going to remove the negative 2 from both sides. And doing that is the opposite operation, so that would be divide. So you're going to divide both sides by negative 2. And this is what you end up with. The next step is to get rid of the exponent. So you're going to square root both sides. And of course, what you want to remember, when you square root, you get two possible answers. So the square root of 4 is 2. So one possible answer is 2. And on the right side, when you square root it, you get x minus 2. But another possible answer of the square root of 4 is negative 2. So the square root of 4 can be 2 or negative 2. So when you square root the left side, square root of 4 is either positive 2 or negative 2. And when you square root the right side, the square root cancels with the square. And the last thing to do would be to get rid of what was in the bracket. In this case, it was a minus 2. So to get rid of the negative 2, you're going to do the opposite operation, which means you're going to add 2 to both sides. So you end up with your first 0 being at 4. So that coordinate is 4, 0. And your second 0 would be at 0. And that coordinate is 0, 0. So you can see here, one of the zeros is at 0 and the other one is at 4. So the first 0 is at 0 and the second 0 is at 4. So if your equation is in vertex form and you want to find the zeros, you use SAMDEB, which is to isolate. Second thing you need to know how to do is to determine the Y-intercept. So there's two different ways to determine the Y-intercept. The first way is to expand the expression. So if we start with f of x it's negative 2 times x minus 2 squared, which means you would write it as x minus 2 times x minus 2, and then plus 8. So that's the first step, is because the bracket is squared, when you expand it, it means you have to write the bracket out twice. Now what we're going to do is expand the brackets. So that is multiplying two binomials, and you end up x times x is x squared, x times negative 2 is negative 2x, negative 2 times x is negative 2x, and negative 2 times negative 2 is positive 4. That goes in brackets because it will have to be multiplied with the a value next. And the positive 8 is on the outside. So that's the second step, is to simplify those two binomials and keep it in brackets. The third thing to do is to multiply everything inside the bracket with the negative 2, so using distributive law. So that would give you this. Then the next thing you're going to do is to collect like terms. So we have like terms here, and we have like terms here. 4x plus 4x is 8x. Negative 8 plus 8 is 0. Now, the 0 you don't actually write, but that is indicating where the x and y, the y-intercept is. So that is the c value. So that's the constant in standard form. The c value is where the y-intercept is. So when you write this out, you don't actually write the 0. You just need to know that the constant term is 0, so that is the y-intercept. So the y-intercept is at 0, 0. So that's the first thing that you can do to solve for the y-intercept. The second thing that you can do is to substitute the x with 0. So you're going to take the x and you're going to substitute it with 0. So that is negative 2 times 0 minus 2 squared plus 8. And then what you're going to do is to evaluate. So using either your calculator or BEDMAS, so inside the brackets, 0 minus 2 is negative 2. Exponents, negative 2 squared is positive 4. Multiplication, negative 2 times 4 is negative 8. And then addition, negative 8 plus 8 is 0. So that makes your y-intercept being equal to 0, 0. So for today's work, if you are given an expression in vertex form, like this one, you need to be able to determine the vertex, which you can figure out just by getting the h and k values. So the vertex would be at positive 2, positive 8. Remember that the number inside the bracket is the opposite sign to what it looks like. So the h value is positive 2, the k value is 8, so that's the vertex. And then when it's in vertex form, you need to be able to figure out the zeros. So you use that using SAMDEB. And lastly, you have to know how to find the y-intercept, and you've got two options: expand and look for the constant, or just substitute 0 in for x.